Okay, now let's see how to show list representation. Okay, 4, 2, 3, 1 and 5. Sorry, 6 and 5. Okay, when we have to represent this is as list representation, we write this as 4, 2, first left side, okay, then 3, 1, we close the bracket because left node is done, right? Next we move to the right side, 6, 5. This is how we represent the list representation. Okay, now let's see what is this LCRS representation of a tree. This LCRS stands for left child, right sibling representation of a tree. Now, in here, we have an example. So, now, let's see how this turned into LCRS representation of a tree, of this tree, right? First, we write A. Next, we have left child as B. Next, we have left child. This is left parent, right? H. Next, we have N left. We have in right side or of H. We have right sibling of H, one more J. Okay. Now the left side is completed. Now let's move to right side. We have C, B already in the right side of C. Then we have E. E have left side K and K have right side L. K have left side P and P have right side Q, right? Next, E have F in right side, then F have G and G have M, right? So, this is the LCRS representation of this tree, right? Okay, now let's see what is BST. Binary search tree. Okay? I explained this BST from simple example. Now you see you have 8 as a root node. Then you have 3 and 11 as its left child and right child. Always in BST, the root node and this can identify as parent node as well, right? Your parent node always should less than your left child. Okay? Then your parent node is always should larger than the right child. This is the essence of this BST. Okay, now you have some activities in the board. You have to display this and this into BST, means binary search tree. So now we can see how these we draw, right? First we have root node as 50. The next we have 30. We entered left side because 30 is less than 50. Next we have 70. Obviously 70 is larger than 50. So we entered it as right. Next we have 20. 20 is less than 30. So we added it into left side, right? Then we have 40. 40 is larger than 30. It added to the right node, right? 40. Then we have 60. 60 is smaller than 70. So we entered it as our left node. Last we have 80. We added it to here because 80 is always larger than 70. So this is the BST for this case, right? Next we have this. So first we have root node as 40. Next we have 20. 20 is goes to left side because 20 is less than 40. Next we have 10. 10 is goes to left side of 20 because 10 is less than 20. Right? Always smaller values of your parent node or root node goes to left side, right? Then now we entered 40, 20, 10. Next we have 30. 30 is larger than 20, so we entered it to right side. Next we have 60. 60 is larger than 40 because we entered as a parent node of right side. Then we have 50. 50 is almost less than 60. Right? Now next we have 70. We entered 70 to right side of 60 because 70 is larger than 60. Next, 25. We entered 25 large left side of 30 because 25 is less than 30. Okay. Now I think you have a small idea of BST. So now let's move. We can construct this binary search tree from using pre-order and post-order. Now let's see what is this pre-order traversal. In pre-order traversal, you have 3 steps like N, L, R. First, you have to access the root. Next, you have to traverse left side nodes and then traverse the right side nodes in your tree. These 2 are recursive. Right? Okay, now let's see how this is turned into pre-order traversal. First, you access the root. Root is 50. Next, you go left side, 30. Left side first, 20. Then you go to the right side, 40. Okay, now the left side is completed. Next, we go to 70. And left side we have 60. And right side we have 80. So, this is the pre-order traversal answer for this tree. Okay, now you have these answers, right? This is the first node you access. Then, This is the last condition you have to come, right? And how many nodes in this tree? There are 1, 2, 3, 4, 5, 6, 7. 7 nodes in this tree. Okay. If someone asks A, L, what's the answer? Then you have to calculate the left side nodes. And in here should be R. It should be the answer of the whole nodes in your right side. Okay? Okay, now let's see how to do first order traversal. In first order traversal, we follow this method. L, R, N. Okay? Okay. You have to check the left side nodes, then you have to check right side nodes. Last, you have to check the root. Okay, now let's see how this tree into first order traversal. First, we write 10 because 10 is the leaf node of this side, right? 10. Then there are 25 also in the left side. Then 30. Then we have 20. Then you have 50 in left side. Then you have 70 in your right side and the 60 next and the root node is last. So this is how you have to show first order traversal.